Any questions here to start on things?
Um,
It's the delta math.
We'll talk about that in a minute.
23.
Sure.
I got some weird fraction. And I shouldn't have it.
You shouldn't have a fraction. Sure. All right. Nathan, I'm going to follow your order of work. What variable did you choose to eliminate first?
I got that next by itself.
Okay. So again, A, B, C. So you did like A plus C. Oh, you did substitution.
Yeah, because I think.
Interesting. Okay.
I think it.
Oh, the directions say to use it probably. Yeah. Okay. So x is equal to 4 minus y plus z. Okay. And then you plug that into B and C.
Yes.
Okay. Okay, so if we distribute the 3 through, oops. Why is that? And distribute the negative sign through. And then we'll combine some like terms here. So I have negative 3y and 2y gives me negative y. 3z and 4z gives me 7z. And then I'm going to subtract that 12 over. And then I have y and 5y give me 6y. Negative z and positive z give me 0. And then I'm just going to add the 4 over.
Yeah, I found where I made a mistake. I honestly put a 5 or something. I don't know where it came from.
And this is wonderful news at this point, right, Bloom?
Yeah.
Because I see that, hey, I don't even have to do another substitution or elimination. I can just solve for y right here. And then I can plug back to the next one to get my z. And then plug back to one of the originals to get my x.
I honestly put a 5 somewhere. I think I messed up some algebra.
Those things are hard to catch.
Yeah, I know. I couldn't find it.
Like once you make one like little silly typographic error.
Maybe a 19 over 7.
Yeah. Yeah. All right. So let's pick up where we left off. So last time. So we're gonna just be finishing out section A4 today. So last time in A4 we talked about solving systems with substitution and elimination. We have still one more method to talk about other than substitution and elimination. And we have still have to talk about like what does an infinitely many solution situation look like and how do we kind of use that situation to generate that general solution. So this is going to be an infinitely many solution situation. So let's go ahead and proceed on that. So I'm going to do this by elimination because it says any method. If I take a look at the variables, I would eliminate the z's because I can just add a and b together and then b and c together, and that'll get rid of the z's both times. And that way I don't have to do too much of anything. And if I look now, if I call this equation D and E, if I do negative 2 times D and add that to E, I get 0 equals 0. Right? Hey, come back. I don't know why that works, but it seems to consistently work. So we still want to get a general solution out of this, though. So to do that, what I'm going to do is I'm going to take either D or E. Doesn't matter which one. I'm going to pick D. And then I'm going to isolate one of the two variables. It doesn't matter which one, X or Y. I'm going to choose to get the Y by itself. So I'll subtract 2X from both sides. And then divide by 2. So this situation, I've written Y in terms of X, correct? So X is like the independent formula or independent variable in my general solution. So where there's an X, I'm just going to write the letter X. We know Y is negative X plus 4, or I'm going to just write as 4 minus X, I think, because that's like one less symbol. And then to find Z, what I'm going to do is I'm going to take this guy and substitute it into A, B, or C. It doesn't really matter. I'm going to substitute into A because if I'm trying to get the Z by itself, I love the fact that the leading coefficient there is 1. So I have X, and then instead of Y, I have 4 minus X plus Z is equal to 4, right?
Yeah.
Okay. So now I'm just going to simplify here. So X plus negative X is 0. So I'm left with just 4 plus Z is equal to 4. I subtract 4 from both sides, and I have Z equals 0. So there, my Z was a constant. So if you go back and you look at, it was yesterday, or not yesterday, but last time. Yeah. So remember there was like a bunch of different infinitely many solution situations. What we've just found is one like this, where one coordinate is constant, like the line that we have going is always in the same Z direction. The X and Y direction can change depending on your choice of X or Y, but one of the coordinates is fixed. So that's kind of what's going on there. If that was instead like tilted, so like it was going in all 3 directions, you may have like all 3 components having a variable. But if it's like straight vertical or straight horizontal or straight like coming out of your sheet of paper, you can have a constant for one of them. Now, is that the only general solution? Yeah, the answer is no. I mean, if we had instead of at this step found X isolated x instead of y, you would have generated a different answer with like y, and it turns out this time to be like the exact same thing because the equation is like symmetric, but you could have ended up with that, and that would be acceptable as well. Let's do one more example of this because, again, this is feels kind of weird, I think. For most students, this is one of those things that's like a little bit tricky. Okay. Oh no, that's not the one I wanted to pick, excuse me. Sorry. Grabbed the wrong example. That one had no solution. This is the one I meant to pick. All right. So let's solve this system. Again, I'm going to call these equations A, B, and C. Which variable do you think you want to eliminate first? The A's look the easiest to me, because I see right away if I just add equation A and equation B, the A's will eliminate. And then I can do like 2A plus C and get rid of the A's that way also. Does that feel okay to everybody? All right, so what do I get? I got 3B minus C equals 5. And then I'm going to get 3B minus C is equal to 5. And hey, at that point, it's pretty easy to see there's infinitely many solutions, right? Because my equations D and E are identical. There's no sense in even doing anything more than that, right? Everybody's good with that? So what I'm going to do now is I'm going to solve, or I'm going to isolate either the B or the C from one of these two equations. It doesn't matter which one I do. I would isolate the C because I don't have to muck around with any fractions. So if I subtract the 3B over and then divide by a -1, I have C is equal to 3B minus 5. So I'm filling out my general solution. I don't know anything about A. B is like my independent variable. And then my C should be 3B minus 5. To figure out my component for A, I'm going to plug C equals 3B minus 5 into either equation A, B, or C. I would plug it into B because the coefficient on C is 1, and the coefficient on A doesn't make any fractions, so I love that. So I have -A minus, scroll up here a little bit so I can see. Yeah, minus 2B, and then plus, instead of C, I'll write 3B minus 5. That should all equal 6. So -A plus B minus 5 is equal to 6. Again, I'm trying to get the A by itself, so I add over the 5 to make 11, subtract over the b, and when I divide by -1, that'll give me b minus 11. Boom, done. So there's my general solution. Hi, Dawn. Thanks, dude. Okay. One more solving technique to talk about. And that's the triangular form. So what do I mean by triangular form? I mean that each equation in my system has one fewer variables than the preceding equation. So, for example, this would be something that we'd consider in triangular form. Equation 1 has 3 variables, equation 2 has 2 variables, equation 1 has 1 variable. What's the beautiful thing about this is I have this solution, I can plug it back into the preceding equation to get 1, or to get the equation for y. And once I have the equation for y, I can plug that and z into that equation to get x. So it's very, very fast. So let's just go ahead and do that. Again, I'm going to call these A, B, and C. So we're going to plug C into B. And then we're going to plug in that solution along with C into A. And so we're done. Like very fast, right? The trick is going to be getting something into that triangular form first. So let's look at an example of taking something that isn't in triangular form, putting it into triangular form. So we can just do that real quick, Solverooski. All right. So to put this into triangular form, the first thing I want to do is get the coefficient for x in my first equation equal to 1. Well, I notice this x in the second equation is already equal to 1. So I'm just going to swap equations 1 and 2. So my new equation 1 is just going to be equation 2. And my new equation 2 is going to be my old equation 1. And equation 3, we didn't do anything to. And now what I want to do is I want to get rid of the x's in equation 2 and then get rid of the x's in equation 3, right? So I'm going to do -6 times equation 1 plus equation 2, and I'm going to store that as my new equation 2. And then likewise, I'm going to do 4 times equation 1 plus equation 3, and I'm going to store that as my equation 3. And similarly, oops. Oh, that's right. Okay, so if we go and update what we have now, equation 1 stayed the same. Equation 2 now is going to be -32y minus 14z equals -24. And equation 3 is going to be 28y plus 11z equals 21. Everybody okay with what I did there? Okay. The next thing that I'm going to do, again, if I go back and I look at my triangular form, leading coefficient on the x was 1. The leading coefficient on the y in equation 2 is 1. And then the leading coefficient on the z in equation 3 is 1. So I need to make the leading coefficient 1 for either equation 2 or equation 3 and then swap them. I'm just going to do it for equation 2. So what do I need to multiply -32 by so that it's so that it turns into a 1? -1/32. I'm going to multiply that to equation 2 and then store it as equation 2. So that's going to be y plus 14/32z equals 24/32. 14/32 reduces to 7/16. 24/32 reduces to 3/4. So my new system, x stays the same. Equation 1 stayed the same. Equation 2 is now y plus 7/16 z equals 3/4. And then equation 3 stayed the same. We didn't do anything to that. 28y plus 11z equals 21. So now we need to make this coefficient equal to 1, or I'm sorry, to go away, right? We need to get that y to go away. How am I going to do that? I'm going to do -28 times equation 2 and add it to equation 3. Yuck. Let's see, 28. So that's going to be 49 over 4. Oops, negative though. Yuckarooskies equals negative 21. And then if I add that to equation 3, I get, this is 44 over 4, so that's going to be negative 5 over 4z equals 0. Or just z equals 0. So now if I rewrite my system, again, equation 1 did not change. Equation 2, oh, I'm storing this into equation 3, by the way. I didn't write that part of it. Equation 2 did not change. And then, oops, I gotta write a y there. It's supposed to be a z. Come on. The eraser on this stupid thing is just driving me nutsos. It's just being really difficult today. So there's triangular form. And now you're looking at me like, Mr. Kulik, that stinks. Because that took flipping forever. It was way slower than the other methods. What's the good thing about this? Is that the steps here are totally programmable. So we can retrofit this method into a calculator method. So let's grab that example and show you how to do it. So if you have your calculator with you, I would strongly encourage you to take it out and follow along. Shh. So, you got your calculator fired up. First thing we're going to do is going to press the blue second button. And then a couple buttons down, we're going to look for the matrix command. That's, you see in blue the word matrix above x to the negative 1. I'm going to press that button. Now, I have a bunch of stuff in my in the different matrices on my calculator, so I have some numbers here. Yours are probably all blank. Sure. Everybody's okay? So it doesn't matter if there's stuff here or not. We're going to type this problem into matrix A. So I'm just going to go over to the edit command, and I'm going to select matrix A. So if I look at my problem here, I'm going to have one column for my x's, one column for my y's, one column for my z's, and then one column for my solutions, right? So I'm going to have 4 columns, and then I have 1, 2, 3 rows. So we need a 3x4 matrix. Rows always come first. Columns always come second. And now what I'm going to type into my matrix is just going to be the coefficients. So for the first row, I'm going to do 6, -2, 4, 0. So I can press enter and it'll toggle me to the next entry. Make sure you take the negative sign with the 2 in front of the y. Now if I look at equation 2, what are the coefficients there?
1, 5, 3, 4.
Yeah, make sure you take the 1 in front of the x. Easy to forget that because there's no number there, but we know there's a 1. So 1, 5, 3, and 4. And then we'll do the same thing down here. So I have -4, 8, -1, 5. Okay, and once you've got that stuff entered in your matrix, press second, the blue button, and then the mode button right next to it to exit back out to the main screen. Everybody get their stuff typed in their matrix? Okay. The next thing I want is I'm going to go back to the matrix menu, so I'm going to press second, and then the matrix option. And this time I'm going to move over to the Math tab. So you see at the top where it says Math. So I'm just going to use my right arrow to go over to the Math tab. And I'm going to scroll down to find the command RREF. So that looks like it's Command B on my calculator. Make sure you take RREF and not just REF. You probably did. And then I'm going to do this RREF on matrix A. So I'll go back to the matrix. From the Names tab, I'm going to select that matrix A that we just created, close my parenthesis, and press enter. So if I read the first row, what this first row is saying is 1x plus 0y plus 0z, which is just x, is equal to 0.25. The next row says 0x plus 1y plus 0z is equal to 0.75, or just y equals 0.75. And then 0x plus 0y plus 1z is equal to 0, or just z is equal to 0. Boom. Done. Wonderful checker to have, right? Okay, I think that's it for lunch, right?
Yeah.
Good timing on Mr. Kulik's part. Go to lunch!
Delta math.
Yeah, do some delta mathing. So
Some of it.
we'll tack on to the current homework 27 to 32. So that finishes up the whole of the problem set for chapter A. I also made for you guys for chapter A, where did you go to? A delta math assignment. So there's 4 sets of problems. There's 5 problems in each set. So, oh, I can't look at it that way apparently. What do I have to do here? Sample student page. This one looks good. So solving systems, 3 variables. There's level 2 and 3. I'm not sure what the difference is. They all look the same to me. So there's probably like the numbers are fractions in one and not fractions in the other. Woo, scary. There's solving linear systems by graphing. Keep in mind that it also says state the coordinates of a point in the solution set. So you just pick something in the solution set also. So like you draw your thing and do your shading, like boop, boop, choop, 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 just like whatever you need to do. And then the last one is you get a story problem. So you have to decide like what type of inequality you want. You write the equation, you plot it, you do your shading and your lines and all that. You may need more equations or less equations, but it all based on the story problem. All righty. So spend the next half of class. You can work on the book homework. You can work on the Delta Math. Both are due Sunday at the usual bat time. I'd suggest do the Delta Math now. So if there's like you run into something like I can't get this thing to work, you can come talk to me and we can figure it out. Particularly those last couple that are like you have to do some graphing and maybe that's hard or whatever. Just getting it to like do what you want it to do. Anyways, but that's the gist of the rest of the class. You guys cool with that?
Yeah.
Pretty chill?
Yeah.
All right. Get your stuff out and get crack-a-lack and let's make some good progress and not have so much to do on Sunday, right?
Exactly.
All right.